3.4, Year 10, this is domestic electricity. These are all questions from foundation papers. Here's your formula sheet. We're going to be using mainly these ones and maybe the P power one, sometimes energy, I think, but we'll see. We'll see what crops up. Let's have a look. So your first question, on about dishwashers, rated A to G. They're just saying that the ones rated A use less energy than G. Then they're going to give you a table, some information. So you've got dishwashers A, B, and D. Notice there's no dishwasher C there. All the same voltage because that's UK voltage. Your currents are slightly different, and then your units used per year are going to be different. And the first question asks you to calculate the power when given the voltage, which is here, and the current, which is given here for dishwasher D. So that's 230 times 8. If you weren't given the equation, it's going to be in the front sheet down by here. And we're just using this equation here. P equals VI. I is tied together with V, so P is going to be pushed up if you wanted to do a triangle there. And then I've worked the power out to be 1840 watts. It's not in kilowatts, just in watts. And then circle from this below the units used for dishwasher C. Well, there's no C here, so we just have to estimate it's going to be anywhere between 315 and 420. And the only one that satisfies that is 350 there. 430 is too big, it's way above D, and then 310 and 200 are way below B. So that's why it sits nicely in the middle, 350. And then I'll leave that out because I think we need that. Yeah, we do. Homeowner buys a dishwasher rate D. Use the equation cost equals units times cost per unit. Well, it's given the cost there per unit of 20 pence. Again, if we weren't given this equation, it's going to be this one here, okay? Because we've already got the units used. They've already calculated that for us. So there's two equations wrapped up in this one. This one is the one we want. So it's just a case of 420 times 20 pence. My 420 I've got from my table, 420 units there, right there. Because it's dishwasher D. And that come out to be £84 because 8,400 pence is the same as £84. We need to underline the correct words or the sentence. So dishwasher rated A costs half as much, the same, or more. Well, it is half as much because when I look at the table, 420 units for dishwasher D, and then dishwasher A is 210. So that is half. Half of 420 is 210. Therefore, if the cost per unit is the same, which it is, it's going to be half as much. So it's going to be half of £84 is going to be £42. Pound, which I've kind of done there, and it's relevant to this question because it says the homeowner could have bought a dishwasher rated A, but it cost £35 more. Is it more cost effective? Yes, it is, because even though it costs £35 more, you save £42 in just 1 year. So it's a bit of a no-brainer then. You continue to save that every year then. So it's a bit like a mobile phone contract when you're summing up or when you're weighing up the pros and cons against a high cost on the phone and then lower cost on the contract, or do you get a higher cost on the contract and then you get your phone for free, that sort of thing. It's given this time equals units used over power. But again, if they didn't, you were going to get it from this one. And then because power and time are just together, you just shift the units up and you do that triangle, and then time equals units used over power. Just out of interest, this is exactly the same question as exactly the same equation as E equals PT, like power times time, only this time is in seconds, power is just in watts, and your energy transferred is in joules. Whereas when they use it for electricity, we don't use joules, we use kilowatt hours. Your power goes to kilowatts and your time goes to hours because we're dealing with such big numbers. So it's giving you the equation there. I'm going to pull my power from my calculation in part A, which was 1840, but that's in watts. Now, I made the mistake, you can see here, of doing it the first time and then I realized I was wrong. So I need to convert that to kilowatts in order to get my hours. And the way I do that, if I'm going from watts to kilowatts, I'm going from I'm going from small to big. So S, small to big, I'm going to divide by 1,000. So BSM, SBD, be smart, mate, stop being dumb. That's how I remember that. Well, I do remember it with another way, but can't go into that one. And then it's going to be 1.84 on the bottom, which comes out then to be 228 hours. I've just rounded that up to no decimals there. And then let's just shift that, so it's nice and tidy. This question was a killer, but it is number 6 on the foundation. So it was one of the first questions on the higher paper. Right, this bit's not too bad. So you've got a bit of bump there. I'm going to just read what it wants. So use your calculations, equations from page 2 to calculate the cost of the washing clothes. So the fact that it's 4 marks suggests you've got to do 2 equations. So here we go. Here's my equations that I get from here, because I'm dealing with electrical energy. How do I know I'm dealing with electrical energy? Because it kind of tells me in the bump. And I've got my power and I got time. And the only, and it's looking, and it gives me the price per unit of electricity there. So I know I'm going to be using these 2 equations. So let's do that. It wants it for washing clothes at 40%. So my power is 500 watts. Well, I need to convert that to kilowatts. So that's going to be 0.5 kilowatts. And my minutes need to go to hours as well. So I've already done it there. Look, 1 hour is 60 minutes. 90 minutes is 1.5 hours. And 120 minutes is 2 hours to make it easy for me. So my units used is 0.5 times 1.5 hours. That's where I get this from. And that's going to give me 0.75 units. Now, if every unit costs 16 pence, I just times those together. I use that equation at the top. Look, cost equals units used times cost per unit. I don't know why I've done them like that. The green one should be on top, really. And it's going to cost me 12 pence to run that. Okay, so this question, I don't want to really spend too long on this for 3 marks, but it's a numeracy question. The Energy Saving Trust, they suggest that washing clothes at 30% reduces energy by, 30 degrees Celsius, reduces energy by at least 40%. Right, so at 30 degrees, and I've got this information from the table above, 0.5 times 1 is going to give me 0.5 units. At 40 degrees, it's going to give me 0.75 units. So, is 0.5 units more than 40% of 0.75? That's what it's saying. It's saying that, I know I've done 50 degrees there, but it's pointless doing 50 because at any other temperature, so the closest one, I want to really see if 0.5 is 40% of 0.75. That's what I want to see. And the easiest way to do that, because I suppose I'm a teacher and I'm always used to doing percentages of how many marks you've got out of a test, it's really saying, is 0.5, if you got 0.5 marks out of 0.75, is that 40%? So let's have a look. 0.5 over 0.75 equals 0.67. So that's giving me 67%. And you think, oh yeah, that's okay. But now I need to take it from 100. And it's actually 33% of that. So if I reduced this by 40%, and that's another way I can show you, I've done it in green. In fact, we'll do that, and I'll show you that it's still not right. 1% of 0.75, where am I getting that information from? I'm getting it from there. If I times that by 40 then, because it wants to know 40%, is this going to be 40% cheaper? Or, less energy? I'm going to come up with 0.3 units, which is nowhere near 0.5 units. So it's false. The statement's false. The energy trust, they're saying if you wash your clothes at 30 degrees Celsius, it's 40% more efficient. You use 40% less energy. Well, that's false because you use 33% less energy. And if you reduced it by 40%, you'd only have 0.3 units there. Like I said, I'm not going to spend ages on that. Mr. Woolley's the guy to talk to on that. I'm going to finish this question and then start another video then. Washing clothes at 30% saves money on household bills. Explain why reducing energy consumption also helps the environment. So there's your token energy question. You're going to say for 2 marks something along the lines of, well, if you use less energy using less crude oil for energy production, therefore there's less CO2 emissions, carbon dioxide. Therefore, there's less greenhouse gas effects. You can also chuck in the sulfur dioxide argument, where it's, less acid rain. Okay, so for 2 marks, any of those. You've got a ring main circuit then. State which wire the fuse must be connected to. Fuse is always connected to the live wire. And describe the function of the earth wire, which is, if there's a fault, it's going to develop. For example, in brackets, live wire touches metal casing, close brackets. It will take the current safely to the ground and prevent you from being electrocuted or prevent an electric shock. It also, as a side note, carries the current at a lower resistance. So it's actually a thicker wire. And therefore, the RCCB then can actually detect that difference between the live and the neutral wires. Very interesting. You will do this question, then I'm going to start another video then. When the voltage is 230 volts, the average power for the washing machine is 500 watts. However, it can be used at a maximum power of 2,400 watts, and that's the one we really got to take into consideration. The household has 3 amps, 5 amps and 30 amp fuses available, and they choose to fit a 3 amp fuse. Investigate whether or not this is a suitable choice. So for 3 marks, I've got this equation. So I'm dealing with, what am I dealing with first? I'm dealing with voltage, I'm dealing with power, 2400. I haven't got to convert it to kilowatts because it's just a standard equation. I'm looking for current because fuses deal with current. So I'm going to go to my front formula sheet, PVI. P gets pushed to the top because V and I are together. So let's bring them back down there. So I've got this PIV, PIV. I need current, so I put my finger over I, and it's going to be P over V, which is 2400 over 230, gives me 10.4 amps. Now, a 3 amp fuse is not suitable. We keep melting. It's rated less, so they would need to use a 13 amp fuse. So I'm going to push this up. I'm going to write part 2. So that I can know where to stop it.